In this lesson, we're going to focus on evaluating inverse trigonometric functions, and specifically with compositions of them. Now, as a reminder, here I have the graph of y is equal to sine of x. And from this graph, we were able to define an inverse trig function, which we called arcsine. But to do that, we had to restrict our attention between negative pi over 2 and pi over 2. The reason for this is an interval where you would have a one-to-one function for sine. So just as a reminder, the inverse is only defined when we restrict our attention between these two angles. But once you do, you can now define what we call arcsine or sine inverse. And the difference between these two functions is the sine function takes an angle to a number, and the inverse function takes that number back to the given angle. So to write a couple of examples down, if you have sine of pi over 2, this gives you 1. And the reason for this is, at pi over 2, it goes up to a value of 1 here. And sine inverse, or arcsine of 1, is equal to pi over 2. And that is because, you start here at 1 and have to go back to this point, which takes you to pi over 2. But what is sine of sine inverse of 1? What does this mean? How would I evaluate this type of expression where I'm using compositions with inverse trigonometric functions? The way I think about this is I start with this value 1 here. I'm going to locate that thing on the axis. So here is 1. When I put 1 into sine inverse, the first thing that happens is that 1 goes over here, which means we're referring to the angle of pi over 2. So step 1 is I'm going to replace the sine inverse of 1 with pi over 2. But then sine of pi over 2 takes us back to 1. What all of this says is if you have sine of sine inverse of 1, that's the same thing as doing nothing to the number 1. You end up right back where you start. Sine inverse goes to pi over 2, but then the sine function takes you back to 1. So it's kind of no surprise that the answer here was the same as the number that goes here. These two things end up being the same. Let's explore this in a few more examples. In example 1, I want to evaluate the following expressions where we have compositions using inverse trig functions. So let's start with this one, sine of arcsine of a half. Based on the previous slide, I kind of think the answer is going to be a half. Arcsine of a half goes to some angle, but then sine takes that angle back to a half. Let's see if that actually happens. For starters, on this unit circle, the way we defined inverse sine was between negative pi over 2 and pi over 2. So from here, that's negative pi over 2, to up here is pi over 2. To figure out what this thing is equal to, I'm first going to focus my attention on just the arcsine of a half. What is arcsine of a half? Well, arcsine of 1/2 is equal to some angle, which I'll call theta. What angle is that? Well, it's the angle that when you plug it into sine, it gives you 1/2 back as an answer. And I just happen to know that that is a 30-degree angle. And I'll use radians, which is pi over 6. So we have that sine of pi over 6 is equal to a half. And that's the one I want to use for arcsine because the angle pi over 6 is between negative pi over 2 and pi over 2. What all this means is, well, first, arcsine of a half gives you the answer of pi over 6. But then sine of pi over 6 is going to take you back to a half. This verifies that, the answer, it's definitely equal to a half. Let's write it out just to be really sure. So we have sine of arcsine of a half. we just figured out that the arcsine of a half is pi over 6, and sine of pi over 6 is a half. So it's, again, looks like almost like nothing happened. I started with a half, and I ended with a half. And it's no surprise that that happens because sine and arcsine are inverses of each other. Does the same thing happen over here for sine of arcsine of a different number, which this one is negative 1/2? I'm thinking it does. I'm thinking the answer is negative 1/2, but let's just double check this. For starters, I want to figure out, well, what is arcsine of negative 1/2? Like, what is this thing equal to? I know the angle is not going to be pi over 6, but the angle I want to use here is going to be negative pi over 6. I know that sine of negative pi over 6 is equal to negative 1/2. Pi over 6 is between negative pi over 2 and pi over 2. Okay, therefore the answer to this thing is going to be negative pi over 6. If we now use this back in the original expression, let's see what happens. Okay, we have sine of arcsine of negative 1/2. Well, that's sine of negative pi over 6, but we already decided that sine of negative pi over 6 was negative 1/2. Same thing happens. We started with negative 1/2, and that's what we ended up with. Again, kind of no surprise here, right? I mean, this is a function and its inverse. They should cancel each other out, leaving you with the value that appears here. And that did happen in both of these examples. In example 2, it seems like the same thing should happen here if we switch to using cosine inverse or arc cosine. Just a reminder, the angles that we're focusing on for this trig function go from 0 to pi. But let's try figuring this first one out. What is cosine of cosine inverse of negative 1? I mean, my guess is that it equals negative 1. That's what I think happens. But to just be sure, I'll first figure out, well, what is cosine inverse of negative 1? It's the angle between 0 and pi that would give me 1 back in cosine. So that is, it's the angle that when you plug it into cosine gives you negative 1 back. And that angle is actually pi. This is where cosine is equal to negative 1. So that is cosine of pi is negative 1. I think that's going to prove this statement up here, but let's just double check it. Okay, cosine of cosine inverse of negative 1 is really equal to cosine of, well, we said that cosine inverse of negative 1 was pi, and cosine of pi is negative 1. So yeah, here we go yet again. We started with negative 1, and that's what we ended up with. So it must be the same thing over here. It's got to be the same thing. This should be root 2 over 2. But, let's just be careful. Okay, I think the first step is going to be, well, what's cosine inverse of root 2 over 2? What does that thing equal? It's the angle that when you put it into cosine, you get root 2 over 2 back. So what angle is this? This is at the 45-degree angle in the first quadrant, which is pi over 4. Cosine of pi over 4 is equal to root 2 over 2. Essentially, I think this proves it for us. But let's just double check, going back to the original expression. Cosine of cosine inverse of root 2 over 2. Okay, well, that's equal to cosine inverse of root 2 over 2 is pi over 4, and cosine of pi over 4 is root 2 over 2. Yeah, I mean, same thing is just happening over and over again. We're starting with a root 2 over 2, and that's what we end up with. Kind of not a surprise. If you compose a function with this inverse, they should in some sense cancel each other, leaving you with the number over here. All right, in example 3, same idea, except we're going to flip it around. Here, the inverse trig function is the outside function, and the original function sine is the inside function. But it kind of seems like, sine inverse of sine should cancel each other. So if I'm just kind of like guessing what the answer is, I'm going to guess that the answer is pi over 6. That's my guess. But let's reason it out, again, referring to the unit circle down here. Okay, since this one is sine uses the angles that go from negative pi over 2 to pi over 2. All right, great. So for starters, this is a little bit backwards. First, I want to figure out what sine of pi over 6 is. Well, sine of pi over 6, that has an exact value of a half. That's great. If I try to draw this on the unit circle, here is pi over 6, and sine at this angle is equal to a half. Okay, I think that's enough to go back to this original expression and show it equals pi over 6. Let's try it out. Okay, sine inverse of sine of pi over 6 is equal to, all right, well, that's sine inverse of sine of pi over 6, we said is equal to a half. But sine inverse of a half gives you the angle of pi over 6 back if we're between negative pi over 2 and pi over 2. And so my answer is pi over 6, no surprise. So this thing here was equal to this thing here. I'm thinking the same thing will happen over here. Here it's the inverse trig function on the outside and cosines on the inside. So I'm thinking the answer is going to be pi over 4. Gotta be a little bit careful here. For cosine, arc cosine, we're using the angles that go from 0 to pi. So just want to be a little bit careful there. Okay, pi over 4. Okay, pi over 4 is here. That's a 45-degree angle. And cosine at this angle is equal to root 2 over 2. Let's see if this can help us figure out what this expression is equal to. Okay, arc cosine of pi over 4. Okay, that's equal to arc cosine. Cosine of pi over 4 is root 2 over 2. And we said since we are restricting our attention between 0 and pi, the angle for which arc cosine will take on the value of root 2 over 2 is pi over 4. And, okay, it happened yet again. This and this were the same. Same idea in this example. Let's simplify sine inverse of sine of 5 pi over 6. Okay, is that going to be equal to 5 pi over 6? Let's see what happens. Well, for starters, as I've been saying before, we're using the inverse for sine. So this is where the angle must lie. They must lie between negative pi over 2 and pi over 2. Okay, great. For starters, if I want to simplify this expression, step 1 is figuring out what sine of 5 pi over 6 is equal to. So let's start there. Okay, sine of 5 pi over 6. One thing to note is that 5 pi over 6 is outside of this interval. It's roughly over here somewhere. So if you want to figure out sine of 5 pi over 6, 5 pi over 6 is this angle, roughly. It's 1 less than 6 pi over 6, which is pi. You go backwards pi over 6 this way. Oh, if you want to figure out sine of this angle, we'd have to use a reference angle back here in the first quadrant. That angle is going to be pi over 6. The reason, again, for that is, well, the y values are the same here. So sine of 5 pi over 6 will be equal to sine of its reference angle, which is just pi over 6. And so maybe I'll just state that up here. Well, sine of 5 pi over 6 is really sine of pi over 6, and that's equal to a half. Okay, great. But now what we want to do is figure out, Well, I figured out that sine of 5 pi over 6 is equal to a half. What is sine inverse of a half? Okay, so sine inverse of 1/2 is equal to, it's not equal to 5 pi over 6. We define sine inverse to only give answers between negative pi over 2 and positive pi over 2. So I don't want this angle. The angle it's going to give you back is this angle here. It's actually pi over 6. What does that mean? It means my initial guess was actually wrong. That is incorrect. So here's something you have to look out for. Whenever your last step is to apply the inverse trig function, you might not actually get the angle back that is here. In fact, this time we don't. The actual answer is pi over 6. Let's just think about what happened. Step 1 was figure out sine of 5 pi over 6. We had to draw an angle that fell outside of this interval. Then to figure out sine of 5 pi over 6, we had to go back here to determine, well, what's a reference angle that I can use to figure out sine of 5 pi over 6? The angle was pi over 6. That gave us a half. But when you put 1/2 in place of sine of 5 pi over 6, the inverse function takes you back to pi over 6. So this is kind of tricky here. You gotta be careful. When you apply an inverse function, you might not get this angle, you might get something different. I think something similar will happen with this here. I'll put this on the next slide. All right, what is arc cosine of negative pi over 4? To start with, since we're using the inverse function for cosine, the angles must fall between 0 and pi. So that's from here to here. And the angle of negative pi over 4 is here. So I already know that the answer is not going to be negative pi over 4. That would be incorrect. But what will the answer be? Your answer has to fall over here somewhere. It's got to be equal to something from over here. So let's just be a little bit careful. I'm going to do a two-step process. First, well, what's cosine of negative pi over 4? Can I simplify that thing first? So cosine of negative pi over 4, that is equal to, well, I think it's got to be equal to cosine of the reference angle, which is positive pi over 4. So here's pi over 4. Cosine is the x value, and the x value there is root 2 over 2. The x value between this quadrant and this one does not change. Cosine's positive down here. So cosine of negative pi over 4 is also equal to positive root 2 over 2. How does this help us? Here's how. Arc cosine of negative pi over 4, that is equal to arc cosine of root 2 over 2. Because for this angle or this one, cosine takes on the same value, root 2 over 2, and is positive. If you want to find arc cosine of root 2 over 2, you have to choose an angle from either the first or second quadrant that makes this true, something between 0 and pi. The only angle that works is positive pi over 4. And so that's my answer to this problem. Okay, same idea. What is sine inverse of sine of negative 7 pi over 6? I know the answer is not going to be negative 7 pi over 6 because that's not within this interval. Well, where is negative 7 pi over 6? That says you start here, you rotate until you get to negative 6 pi over 6, go another pi over 6, and this is the location of negative 7 pi over 6. The reference angle for this angle is positive pi over 6. So what this means is sine of negative 7 pi over 6 is equal to sine of pi over 6. So maybe like a quicker way to think about this problem is, well, sine inverse of sine of negative 7 pi over 6 is actually equal to sine inverse of sine of pi over 6. And the reason is because the two things here, the y values at these two angles, are equal. Now, since pi over 6 falls within this interval and negative 7 pi over 6 does not, means these two trig functions will cancel, leaving me with pi over 6 left over. That's why pi over 6 is the answer to this problem. Let's try this for arc cosine of cosine of 5 pi over 3. So same thing. Again, I'm thinking about arc cosine. So my angles are coming from 0 to pi. Okay, but where is 5 pi over 3? Let's see. Well, one full rotation is 2 pi. That's 6 pi over 3. So if I go backwards pi over 3, this is the location of 5 pi over 3. It's here. Let me draw that on. Okay, a reference angle to 5 pi over 3 is going to be pi over 3. And the reason is, here you'd go up pi over 3, here you're going backwards pi over 3 to get to this angle. So cosine between these two angles is the x value of those points, and they're equal to each other. So said another way, arc cosine of 5 pi over 3 is equal to arc cosine of pi over 3. Those things are equal. But here, since the pi over 3 falls within this interval, my answer will be pi over 3 instead of 5 pi over 3. And that is the answer to this problem. All right, let's figure out cosine inverse of cosine of 5 pi over 2. The answer is not going to be 5 pi over 2 because that is outside of the interval from 0 to pi. All right, so I guess for starters, where is 5 pi over 2? If you count by pi over 2s, there's 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2. Here's 5 pi over 2. It actually falls right on the axis here. So this is the location of 5 pi over 2. So it's like you do one full rotation and then go another 90 degrees. This is also the same location as pi over 2. Now, 5 pi over 2 and pi over 2 take you to the same spot on the unit circle. The difference is that pi over 2 is between 0 and pi. What does this all mean? This means that cosine inverse of cosine of 5 pi over 2 is equal to cosine inverse of cosine of pi over 2. And that's because these two things are equal inside the parentheses here. Now, I can cancel these two trig functions, and I'm left with pi over 2. And the reason I'm allowed to do this is because pi over 2 falls within this interval from 0 to pi. And for tangent, just a reminder of how that worked, we are only using angles between negative pi over 2 and pi over 2. But for the tangent function, we excluded negative pi over 2 and positive pi over 2 just because tangent is not defined there. Okay, so what is arctangent of 4 pi over 3? Well, 4 pi over 3 is definitely not within this interval. Where is 4 pi over 3? Well, pi is 3 pi over 3, so if you go pi over 3 more, 4 pi over 3 is, here. So pi is the same thing as 3 pi over 3, and we're going one more than that to give me here. Okay, what is a reference angle for 4 pi over 3? That angle would be pi over 3, which is here. It turns out that tangent of 4 pi over 3 and tangent of pi over 3 are equal to each other. This is great. That means I can replace tangent of 4 pi over 3 with tangent of pi over 3. That's exactly what I'm going to do. So this is arctangent of pi over 3. But here, since pi over 3 falls within the interval from negative pi over 2 to pi over 2, I'm essentially canceling those two trig functions, and I have pi over 3 left over. And that's my answer here. In example 6, let's evaluate this expression here. Cosine of sine inverse of 3/5. This is very different than the problems that we've looked at because here I have cosine, but inside I don't have the inverse of cosine, I have the inverse of sine. So how could I simplify this thing? To do so, I'm going to use a right triangle as a guide as opposed to using a unit circle. I'm going to focus on the sine inverse of 3/5 part first. So sine inverse of 3/5, what is that? Well, I know it's equal to some angle. The sine function takes angles to numbers, so the inverse takes a number back to an angle. In fact, if you re-express this in terms of not sine inverse, but the original function sine, this is the same thing as saying sine of theta is equal to 3/5. The reason I'm going to use a right triangle to solve this problem is because we define sine as the opposite over the hypotenuse of some given angle theta. Well, I have a fraction for sine. The top is 3, the bottom is 5. I can label these things on the right triangle. The opposite is 3, and the hypotenuse is 5. So let's label that. This is 3, and that is 5. Okay, great. So if you want to know cosine of sine inverse of 3/5, you're really asking, well, what is cosine of theta, where theta is this angle here? And we define cosine of an angle to be the adjacent over the hypotenuse. And, oh, well, we know the hypotenuse is 5. The only thing that we don't know is the adjacent side. What's the length of this thing? If I know it, I'll have my answer. To do that, I'm going to use the Pythagorean Theorem. I'll call this side A, this is B, and this is C. And the Pythagorean Theorem states that A squared plus B squared is equal to C squared. I don't know A. I know B is 3, and I know C is 5. A squared plus 9 is equal to 25. If I take 9 from both sides, I get that A squared is equal to 16. If I take the square root of both sides, I get A is equal to plus or minus 4. But here we're talking about length, and therefore 4 is going to be the length of the adjacent side. So what is the answer to this problem? It is 4 over 5. Two-step process. Think about the inside part, the inverse sine, and note that it is an angle. If you change it to an original trig function, you can label these numbers on the sides of a given triangle. And then once you do that, you can solve for any of the other trig functions. And for this one, we did cosine.